In this section, we're going to try and learn about some of the ways of calculating investment returns. This will borrow heavily from what we had discussed already in terms of our discussion in NPV versus IRR calculations. When you are calculating returns on a particular instrument, it in effect is trying to find out what is the return that you have generated on a series of cash flows. So what you see here is an investment amount that has happened on the 1st of January 2010, 1st of January 2011, 1st of January 2012, so on and so forth. So these are a series of cash flows, and each of them till this period has been invested at a certain rate R. This one for a period of 6 years, this one for a period of 5 years, this one for a period of 4 years, and so on and so forth. Right? Now, technically, I can do this calculation and then solve for R. When I solve for R, obviously it becomes an equation that cannot get solved easily. So you have to use what is called as trial and error, right? What helps you do trial and error is basically the function IRR, internal rate of return. Remember, IRR assumes a certain series of equidistant cash flows. When I say equidistant cash flows, they mean that the cash flows happen at a regular frequency of 1 year each, right? This is what is happening. And so this person has invested 1 lakh, 20,000, 4 lakh, 1 lakh, 20,000, 80,000, 75,000 on these days. And this is the final value. So in a sense, this value has to be negative. So this is the value that will come out of all the investments. These are the values that are investments that have been done. If I solve this for IRR, if I solve this equation for IRR and select this entire set of values, that is going to give me what is the return on this particular portfolio, right? So this portfolio on an annualized basis has made 11%. So if I replace 11% in that equation for a 6-year period, we will see that we will end up with a number that is equal to 12,010,000, right? Let's try that as well, just in case we are not 100% certain. So this is 100,000 into 1 plus 11%, and let's freeze this to the power 6, and then you have this. Let me drag all of this down and then I'll change them individually. So this instead of 6 will become 5, this will become 4, this will be raised to power 3, and then 2, and then 1. Now let's format all these, and when you do a summation of all these, you find that you end up with the same value, 12,01,000, which means the data correctly corroborates the calculation of 11.66%. That is the annualized return on a portfolio. So if the investments are at regular intervals, then you can use what is called as IRR as a function. Now that in reality may not always be true. In reality, investments may happen at different points of time. You could have on 1st of January, you could have on 10th of January, you could have on 21st of March, you could have on 3rd of May. Investments can happen at any point of time. Now here, we did not take the date element anywhere. The IRR function basically just selects the series of cash flows and assumes that the first cash flow happens now, the second one after that, the third one 1 year after that, the fourth one 1 year after that, and so on and so forth, right? So in this case, we can only solve it if the cash flows have been at regular intervals or investments have been at regular intervals. If not, then the problem gets compounded, and in that case, you solve it using a function called as XIRR. So let's understand what is XIRR. Let's look at this series of cash flows now. So we have on 1st of January a certain investment, on 8th of August a certain investment, 5th of Jan another investment, 12th of March another investment, 20th June, 30th June, 1st of Jan. Now if I select this, it'll and do a simple, and let's say I change this value to a negative value here itself. I'll change this to a negative value. If we do an IRR calculation here, that's going to give me the same answer as the last time. That's because the dates are not taken into consideration. So that same answer comes out here as well, right? But to solve this problem, basically you have to identify for how much time has this money been invested. So this 1 lakh has been invested for 5 years, 1st of January till 1st of January. This 20,000 has been invested from 8th of August till here. So whatever number of years, 4 years and 3 months and some days, or 4 months and some days, it has been invested for. This has been invested for 3 years and 360 days roughly, right? 4 days after the first day, 5 days after the first day. So 3 years and 360 days it has been invested in. This one is lesser. So that equation, when you solve, for solving that equation, you need XIRR as a function, right? So we will write XIRR here and try and understand what are the elements of XIRR, or what are the parameters that XIRR takes. When you open this, you will realize that XIRR takes the values. That's the first part, similar to IRR, but then it also takes the dates. It also takes the dates to know when those cash flows are happening. The guess is any number that you can put in. If you think the result is close to this, you can leave it blank. What is the result we get? The result is 12.51%, right? That is the correct return in this case. So effectively, if you are facing the prospect of looking at irregular investments, cash flows, then that can be solved by using a function called as XIRR. Extended IRR is what the function name is. This includes the values, and this also includes the dates on which those values have come in as parameters to this particular function. That is how you calculate return on portfolio of investments. IRR and XIRR used in solving those.